the UK. So the sun delivers the equivalent of 340 watts of energy per day per square metre. That's the average for the whole of the planet. Of course, if you're in the equator, you're getting way more than that, but if you're in Bristol, you're getting substantially less, and if you're North Pole, that's where there's ice. So there's this vast amount of energy, but it's very dispersed. But it's the equivalent of 440 million 100 million watt power stations. That's a power station for every 10 people on the planet. How much are we gathering through our exciting renewable energy technologies? Wind, wave, that's all wind, that's all solar power, solar electric and solar hot water. We can currently capture 1/40,000th of 1% of that available power source. Of course, if we captured it all, the planet would die, so we don't want to do that. But we could be doing a whole lot better, but I'm not going to bet too soon on renewable energies, although we will see some very exciting innovation. But that's an emerging process, but we've got targets that have to think differently. So where does all this energy go? Well, apart from driving our weather system and climate change, it drives our biosphere. And nature has evolved a way of capturing carbon dioxide, bringing that into plant and phytoplankton material, taking off the oxygen atoms and dumping them as a waste product to atmosphere, means by which you and I live, and then takes that carbon atom and locks it into cellulose complex sugars to make the building fabric of plant material. Could we borrow some of that? And yes, we have. Building with natural materials is nothing new. Thatch, timber, it's been around for a long time. But the interesting thing about this is that in a cubic metre of timber, there is 800 kilograms of CO2 equivalent. So the Germans are now doing carbon capture, so they scrub CO2 out of the atmosphere, they put it into a can and then pump it under the ground, and let's cross our fingers that it doesn't leak. If you want to split carbon from carbon dioxide to make hydrocarbons for fuel, and you can do that, you can make energy out of air. You have to heat carbon dioxide up to 2,500 degrees C to split that molecular structure. Nature does it with sunlight and water, with no energy exchange that we are able to perceive, not 2,500 degrees. So it does that at ambient temperature. That's quite a trick, and if we could patent that, we'd have a go. The Monsanto have tried it with rice. Maybe we'll have a crack at patenting cellulose or photosynthesis. So, what are the ingredients of what we're working with? We're working with wood, straw, or hemp, and lime render. Now, there's no fruit in any of our products, but it makes for a better PowerPoint slide, and because lime render is a rather dull grey material. This is limestone, I think. It could be sandstone, but it's limestone. Limestone, that's bio-evolved carbon capture. It's fossilized carbon. Your bone structure is made out of calcium carbonate. You don't photosynthesize, but we eat animals and plants that do. So you are solar energy. You are stardust, starlight. Well, not stardust, you're actually starlight. So, and then we have some stainless steel and screws in our product. So what do we do? The question we asked ourselves was, all of this stuff is wonderful, but deep green and hairy. Straw bale, and most of the images that went through your head when they said straw bale, was probably more Little House on the Prairie than something terribly commercial. And that's fantastic. Those individuals who have built their houses out of straw are brilliant, and we think they're fantastic. But our question was, how do you take that stuff and deal with the hairy-ass construction industry and all of the supply chain issues? And how do you drive this kind of material into that system? So we go and copy people. We go to IKEA and look at a flat pack system of engineering the framing which could hold our straw and or hemp. Then we balloon it up. That's copying the way timber frame buildings have been done for millennia. And then we fill it with straw, which we grow locally, and then we use local skills and labour to do that. So these are what the panels look like. Highly engineered, solid timber engineering. So they are structural, they hold up buildings. That's a straw one, and then the one on the right is a hemp one. We use fully certified logs. If anybody's involved in the specification of building materials, you have to make sure that the forestry from which you're drawing your wood is legal and sustainably managed. And the rule is, for every one tree you cut down, you have to plant 3. There are standards which go up to a 1:9 ratio of planting, but we currently source our engineered timber from Switzerland because there is no engineering of timber at this sort of technological level in the UK, or should be, and I know the RDA Southwest is kind of looking at whether there's a market for that sort of engineering, and we would like to be part of driving that market. So this company, it's 180 years old, buys logs with bark on it, comes in, typically for European timber engineering, they've got things like X-ray machines that X-ray the timber, whereas we go and give it a kick in the UK. And they then X-ray it, and then the high-value stuff goes into products like ours, the low-value stuff goes into sheets and other sorts of material. This company has also invested in hugely in CNC, computer numeric cutting tool, so we can then create very complex shapes simply by subtracting that material, and of course that subtracted material goes into the biomass boiler which powers the factory. We then make jumbo plywood, which is sheets of solid timber, a bit like an enormous great big chopping board but the size of building components, out of which, if you can make a cardboard model of a house, we can cut it up using this technology and build it. You glue it together, we'll screw it with screws this big. So that's what it looks like as a drawing. That's a 3-bale panel with a 1-bale window opening. There's some solid 3-bale panels. The funding part, we are funded by the Technology Strategy Board. Thank you very much for that. That is helping us do all of the backfilling that we need to do. It also helps us predict about some of the performances we need to be able to achieve because we started building this stuff before we actually knew whether it was going to work. That's because we were building off of other people's risk taking as well. We're also funded by the Carbon Connections, which is a HEFCE funded system, and that's all of our funding. We partner with the Centre for Window and Cladding Technology, Bath University, Lime Technology. Integral is a structural engineering practice that owns ModCell along with White Design, the architecture practice. Agrifiber Technology is a company specialising in the use of agrifiber technologies into construction. And Urban, the people who help us do the solid timber engineering. We have to do lots of structural testings. Buildings must not fall down. So this is us tipping a big fat panel over to see whether the straw falls out. We don't want that happening. 15 minutes later, we realise it's pretty strong, and then we put 13 people standing on the back of a straw panel. A lot of people think straw is going to be a bit kind of hollow and boxy and a bit lightweight. It's extremely solid material. This is the us, and the key thing of working with organic materials is moisture content. You need to know what levels of moisture content you're working at. High levels of moisture content at very consistent levels cause problems. They can, if you completely seal it, it'll turn into silage. If you let air into it, it'll compost. So we need to worry about that, but we design all of that out. We've currently got accelerated weather testing on Bodmin Moor. That's pretty wet and pretty windy, and we do all sorts of nasty things to straw. And then afterwards we do a strawtopsy to see how it all performs. And the world of building in straw is good fun. We're trying to work out a specification that uses Kenneth Williams' language of have you nibbled your cord wangler yet? But anyway, we don't do that. We're trying to be serious. But we do things like let water in, and we crack the render, and we do all sorts of nasty things to it. So the structural principles. We need to be able to have a system that can hold up buildings. So straw slumps. So what we design is the panels are too small to hold the straw, so we post pretension, our panelling system, which takes out any of the slumping. We then stabilise that, and this is where we see the stainless steel, or we're now working on removing stainless steel out of the system. And then the whole thing works together to create a straw bale panel that can hold a building up. Traditionally, you build with bricks of straw.